and let's like walk through this, right? Like for example, so I'm basically using a Google Colab because this is my personal account where I do all the training and teaching and studying of my own. So basically, see, I have a 5-3 vision. Let's say you were given certain tasks to do, and this is how basically we expect developers to test on their own and come out with results. So for example, again, I took certain tests from different white papers from here and there, collated it and put it that that I was testing out 5-3 vision. I took the 128K instruct demo basically. So where did I use it from? So let's go through all of these. So I have a maths problem. I have a human logical puzzle solution problem. I have a single image prompt problem and I want to solve. I want to do a text VQA type of thing with a 5-3 vision. So that this could be with a mini also, right? A science visual question answering, and then I have two other different things, a confusing photo and a table to a markdown format kind of a workload. So let's go through this. So for example, first I do a pip install transformers, the library I install, and I the flash attention. So transformers basically has the pre-trained, the causal models, right? All of them as part of this. And the flash attention is basically I require also for executing them, these models specifically. So this is basically, serves as a concatenation, basically a library which has all these subclasses connected to the self-attention layers. Now, when we do an auto model for causal LM and an auto processor, then this is basically a generic model class for auto loading the LLMs, right? And this is the auto processor. Now, there are multiple ways of the way how you're deploying. You can just use it from the context of an Azure AI Studio to get started and test it. But from an application perspective, people usually kind of instantiate the models programmatically. That has been our understanding. So here, for example, I'm basically using the Hugging Face. So for example, model path. So I have introduced 5-3 vision, 128K instruct. Then I basically pass in parameters of the processor and the model. And then, once I execute this, right, make sure that if you are using something like this, you have to use an L4 GPU. You do not need 800 GPU. If you are using for 3.5, not the mini, not the vision, you can use any of them. But if you are using the mixture of experts, then technically your pro account will not work. I have a pro, you need to have a pro plus account because you need a good of GPU RAM for the inferencing bit of it if you want to do SFT and all of that. Otherwise, you should use the 800 GPU. For our use case, if you are on these kind of models, L4 GPU is more than enough. So if you use an L4 GPU, as you see, it basically goes, it installs all of this. It basically downloads the shards and it sends up the checkpoints, right? Now in the math problem, let's take a look. So in the math problem, right? So what is the given? So I've asked basically a simple question that give me a code for solving two sum problem. I haven't given anything else, right? So if I give an input like this on the 3.5, right? Sorry, this is on the 3 vision. So it, for example, see the output. It basically gives me certainly here is a Python solution for to some problem. It basically gives me a entire program. It explains how the program runs, and then it explains me basically how to read this. So it basically uses a hash map in Python to store the indices. It's implements, and then if you finish iterating through the array without finding a pair, we return an empty list. So this is how basically it gives you, and I see it's pretty good in that standard sense that it's able to understand, solve it, and kind of give me the program. Now, what about puzzle? Now, I took this from a white paper of complex LLM puzzles, which LLMs always, from a human logical reasoning capability struggle with. Let's throw this to a 3 and see how it solves this. Now, this is basically a farmer wants to cross a river, take with him a wolf, a goat, and a cabbage. Now, he has a boat with 3 secure separate compartments. If the wolf and the goat are alone on one shore, the wolf will eat. I mean, we classically know this problem. If the goat and cabbage are alone, the goat will eat the cabbage. So how can the farmer efficiently bring the wolf, the goat, and the cabbage across the river without anything being eaten? Now, human logical point says the answer is very easy because it is already mentioned that he has a boat with 3 secure separate compartments. So human logical reasoning should be that I put the wolf in a compartment, a goat in a compartment, and a cabbage in a separate compartment, and I'm sitting at the head and driving the, let's say, in the boat, right? So it should be no problem at all. But you see here the SLM struggles. In fact, it gives an incorrect answer. The farmer can bring the wolf and the goat across the river fast, first, leaving the cabbage on the original show, then you can bring the goat. So this kind of struggled with this logical reasoning answer, right? I mean, even larger parameter LLMs struggle with it. This is not an exception because it is on the number of parameters of training. So this is one example of a human logical reasoning. It failed. Image prompt for a simple image. Now let me quickly open and show this image. Otherwise, we will not get a contextual understanding of what that image is. So it's basically a watch in high definition. This is a Rolex. As you see in the image, it is mentioned Rolex perpetual. This is a submarine oyster steel, correct? Underwater, and the image is exactly underwater. So can it understand? So I'm just passing the URL only, correct? I'm not saying anything. I'm saying, can you explain the image? It beautifully correctly shows it. It says the image shows a Rolex Submariner watch with a black dial and a silver bezel, partially submerged in water. I mean, technically it is correct. It's not partially, it's like fully submerged, but it's okay. The watch is surrounded by a blue water surface with bubbles, giving the impression that it is underwater, which is 100% correct. The Rolex is visible. This is absolutely correct. So this is basically technically your TQA, TVQA, happening in real time, right? Is visible at the 12 o'clock position, and the model Submariner is at the 3 o'clock position. This, I believe, Submariner is correct, but not is at a 3 o'clock at the model 3 o'clock. It's not at the 3 o'clock position, but it's fine. It's perfect, like in terms of reading it. And the date function at the 6 o'clock and a small second subdial at the 9 o'clock. And so it kind of gives me this output, right? I mean, this is able to do it. Then I took a actual T-VQA, which is used by marketing, branding, and a lot of use cases we see, right? Even for education. Now, let's first see the image here. What exactly is the image, right? So then we will understand the ability of its output capability, right? So this again, I took from the internet. This is just in the mall someplace in the UK. Banner is there, an advertising banner. These are the ones which automatically change. So this is a Dior advertisement. Very important to note. It is not a Sauvage advertisement. The advertisement is of the brand Dior. Sauvage is one of their lines which they have for the perfume. So the perfume is called Sauvage, and the tagline of Johnny Depp is the new elixir. This is the tagline. So these are different contexts from a human perspective, right? When we look at it, we know that Sauvage is not the brand. It's the Dior which is the brand, right? But can a model do all of this? I mean, is it intelligent enough? So when you run the first one, it says the billboard is advertising the Sauvage perfume by Dior. This is absolutely perfect if you see. The Dior is the brand and the billboard is advertising Sauvage perfume, right? It is not. And the second question of it is basically, what is the tagline in the advertisement? This, if we have some time, we can take a look at. So change the runtime L42. Let's connect it. Kasam, we have some time, I think a few minutes, right?
Yes, but you are free to.
So I want to see this in actual real time. Let's see, because yesterday I was doing some R&D on sizing of like TQV and the science bit of it, VQA. So it has certain limitations around the size and the extraction of the parameter to how depth it can go to. Let's see if that is the case here. But we will not be able to see unless we execute it in real time. So this will take a few seconds, hopefully successfully install the flash attention. And let's wait for it to complete, and then we will take a quick look at it in real time. So it basically does a setup. It then downloads the shards and ensure that if you are testing out with the MOE, it will have 17 shards. I tested out yesterday. So it will take some time even on a A100. So you need a better environment. So Colab Pro will not work on it. You need a Pro Plus account actually. Or if you have dedicated GPUs, excellent. This is pretty fast. So it's a small model, right? So this is complete. I can test this out again. Let's see. And if you see the important bit of it, let's say you were doing this on a low latency, a resource constraint scenario. You can even quantize this model. We did not cover it today owing to brevity of time. That's an entire world of its own. You can take the model, quantize it, and run it on an iPhone. The technical paper had it on 15 Pro, and now the 16 which has come out, and 16 Pro and Pro Max can easily run this even in the much larger one. It'll give you very, very low latency, answer. So see, it's pretty fast actually. So this is a puzzle problem that we are trying to solve, right? Let's see how fast it can execute this. Because it has to basically understand the problem and does logical reasoning on it. I think the O1 which has released will do a phenomenal job on this. But as you see, all LLMs and SLMs struggle in this. This is a real proof of that we still have some distance to go for AGI and to happen. The day of AGI, when it comes, it will absolutely correctly read this and quickly give a perfect answer to this. Can you explain this image? This is fine. This is basically the one which we kind of executed for the Rolex, right? Let's see how fast it can generate this and how much information, because this is a token to token generation. So remember, every output will always be different because it's trying to understand context and then convert that context into a sequence of vectors and then do a probabilistic distribution, right? So output will always vary every time you run a LLM or a multimodal or an SLM even. So let's see, or does it give the same answer? Let's check. As you see, any visual will always take a little bit of more time because it's reading through the network layers. It's trying to understand, and I've given only max new tokens as 1,000, right? So it will have that resource constraint factor as well. It shouldn't take this much time. Hang on. Let me close this and restart this. So if you see the image is opened, it takes the max time in the image of converting this into a .raw. That is where it takes the most amount of time. The generation bit is usually the faster bit of it. And the one which I wanted to kind of understand is if we cancel this and go to this one, the single image prompt, that is basically the brand, the billboard. So this is perfect. So it gives you so fast. So the textual understanding is correct. Now, if I kind of make this as hash, remove this, and I want to understand what is the tagline. This is a much more difficult question. Now let's see how this performs. Now see, this is what I wanted to show. This is near perfect, but not perfect. Why? Because if I now go to this image, let's make this bigger. So it is Elixir, ELIXIR, right? But it says ELXIRI. So it had a very small spelling mistake. So there is always a scope of improving it. Now, where does the causal 𝗲𝗂 appear in the Venus system? Now, this is a very difficult question for LLMs. So let's understand this image first. What is happening here? This is the image of a rat in a laboratory, and then the arterial system and a venous system. This is what students do in biology, right? Or if you have a biology homework project, right? And I'm trying to understand at a very high level that, I would like to understand where does the causal 𝗲𝗂 appear in the venous system. So if you see in the venous system, the caudal 𝗲𝗂 in the image is basically here, correct? It is under the heart, and it basically connects to the right external jugular and the right subclavian. So can it give the output is the question. So it has got disconnected. My bad. Let me reconnect it. So I'm having today issues with changing of the GPUs only. The GPUs have to be available for you to be able to do this job. So if you are doing collab, you have to keep an eye on this ... It should be tick mark at all times. If it's connecting for some reason, then it will show you very poor low latency actually. For some reason, it is not able to. One sec. Yeah, disconnected. Now let's quickly run this. So it should be tick mark at all times. Oh my God. It again went ... So in the meanwhile, before while it runs, let's take a look at the Phi-3.5. Now that is why I have rerun these, in the past. Now in the 3.5, if you see, what basically I'm doing is I do a pip install transformers and attention. I instantiate the causal LM and the auto processor, and then from basically model path, I've changed this to Phi-3.5 Vision instruct. And I'm trying to understand the quality difference. We do this test across models and we run through the basic installation. Now, math problem. Now, uh, if I go up and try and see the math problem, see, for example, when I saw this, it just gave me a code. It did not explain me. Now, in 3.5, look at the difference. So it is basically giving me a simple solution to the two-sum problem in Python. It basically then creates a dictionary to store it. Then it iterates through the list of numbers, correct? And then this function, kind of explains me. And it also gives me an example of how to use this function. So nums, target is 9. So result is num, and then the output is 0, 1. In this case, the two numbers that add up to the target of 9 are 2 and 7, which also have indices 0 and 1 in the list. So it's a much more detailed and technically mature answer and explains you with a question also. So if you see the upgradation now, coming back to one of your question, it's how you instantiate the model. It's not much of an ability. Code practically will remain the same. The output will change. Now in the puzzle one, which I had again passed the same puzzle to it, and it also kind of gave me the same quality of answer. It failed kind of the logical reasoning, right? It goes back and takes the wolf, right? So I think this answering this puzzle is pretty tough. It requires a much more, logically reasoned model to answer this. So I wanted to test this out. So image one is basically the watch one. The 3.5 kind of gave me the image shows a wristwatch with a black dial and a stainless steel bracelet, partially submerged in water with bubbles around it, suggesting it is water resistant. Very precise, correct information, but it did not kind of give me any details like 3 gave in terms of what branding and a lot of other information. It was very precise in what it sees. For the single image prompt, the Savage one, right? Board is advertising the brand Savage. Now, you may translate this in multiple ways, but I would technically say here the 3's answer was better than 3.5. Why? Because 3 kind of gave me that it is of the perfume brand, basically Dior, and the perfume brand was basically called Savage, right? So that's one of the better ways to look at it. And then you had the single image prompt, and yeah, so this basically I kind of executed. Hang on. So manage sessions. If you have a lot of sessions open, let's terminate this first. Close, then change the runtime L4 GPU, reconnect. So for some reason, sorry folks, but today GPU availability was totally purely by chance. But if you, for example, look at this particular image, so let's open this and understand this. This gave a perfect example. So I wanted to understand this particular part. So where does the causal Venn-Ava? So first of all, the model understood what a causal Venn-Ava is. It also did technically a T-VQA, but in science format from an image. And then it basically told me that what was the answer? It is that the causal vena cava appears in the right side of the heart in the venous system. So technically, if you see it, it's where exactly from the heart side it is on the right hand side, correct? I mean, so technically it is absolutely correct in that sense. And then the single image prompt of converting a table to a markdown. Now, this is an important test as well, folks. I will quickly show this so that you have an understanding of what this is. Sorry, folks. I did not copy this correctly. So this is basically this table I have, let's say somebody has provided me, right? So I'm basically asking, can you convert the table to a markdown? I think we failed at this one. So let's run this and then we'll explain this. So now if you run this and basically feed this in and you have said, can you convert the table to a markdown format, as you see exactly. So chocolate 744, it's like if I make this smaller, kind of, if you see 744.60, 162, 907, and all of this has been translated into a tabular format, right? And the sales figures of 2 quarters and their grand total. So this is also perfect in that sense. 3.5. Then this was important. This is very, very important in the sense of understanding how well can it read a confusing image. So let's understand what a confusing image is. Again, there are loads of them available in white papers of LLM tests. So this is, please understand, this is a human person, but the way she is looking at the horse, and it has been taken at an instant time where she's holding the horses or basically something, and then the horse is also visible, but it appears as if it's the face of her. It's technically not. It's a lady wearing a helmet. So the horse is not actually wearing the helmet, right? But she's holding a donut in hand. Pretty complex. Can it read it is the question. Sorry, my bad. So here, basically, let's see. So what does it say is the image is unusual because it features a person wearing a helmet that is shaped like a horse's head. Now, till this much is perfect. Why? Because it's a person wearing a helmet. But here it fails. That is shaped like a horse's head, which is not a common sight. This is an absolute failure because neither her face is like a horse, neither her helmet is like a horse, right? It just so happens that the horse is next to her at the instant the photo is taken. The helmet is attached to the person's head. This is correct. And they are holding a donut. This is also correct. So the horse is not holding, the lady is holding the donut. Absolutely correct. And which adds to the absurdity of the situation. That is also absolutely correct. So as you see, it is able to contextually understand certain layers, but there's also improvement for some because there are a lot of other more confusing images like this. You can do a test. So let's say if you're using 3 and you can see the output differences, possibly you can do with the mini and with the vision and with the MOE. The MOE would definitely produce much better quality answers across all of this. And another thing I did not test out, but I should have had, was the multilingual ability. That is also something that you can test on. So these are the ways of, which you can test and kind of go deep and take a look at, what are the different performance metrics or parameters. So this is what I had for today. And then if any Q&A you have, more than happy to answer, or we can, this is what I wanted to show. This is just the beginning, the scratching the surface. You can take it, of course, as your use case fits it. So it was able to give me this. It is so yeah, so here see the answer was not very good for 3, but for 3.5 it was perfect actually.